Hi, today we are going to be converting decimal numbers to binary using the sum of weights method. There are a few things you need to know when you're doing this. So our general sum of weights define the maximum number you can find with the number of bits. You do 2 to the n being the number of bits, minus 1 equals the largest decimal number that you can find. Okay, so for instance, if we were to have 2 to the 4 minus 1, 4 would be the number of bits that, the number of bits that you are using as a binary number to represent that number, and 2 to the 4 minus 1 is 15. So that means using 4 bits in binary, you can count up to the decimal number 15. Now, for instance, let's do an example of how we actually convert the decimal to the binary. Some very easy ones. For instance, let's consider 4 bits, and let's try to find the binary version of 12, hope this looks like a 2, of the sum of weights method. So 12 is going to equal, our first bit from the right, which will be our first bit from the right, is going to be 2 to the 0, and then you go 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 3, and then that's going, because you start at 0. When you have 4 bits, you don't start at 1, you start at 0. That's very important. So, let's see. Does 12 fit into 2 to the 3? Yes, it does, because 2 to the 3 is really 8 plus 2 to the 2. That is 4. But then we have to do these plus 2 to the 1. Nope, because we've already got our 12, plus 2 to the 0, which anything to the 0 is just 1. Nope. So these are both true. They add up to 12. These don't. So we're going to get 1, 1, 0, 0, and this is going to be 12 in binary. Alright? That was a very short introduction. I can make a few more videos of examples if you want and explain a little better. But basically, that's it. So remember that that you can really find the if you are worried about how many bits you need to represent a decimal number, then you just need to use this for the sum of weights, 2 to the n minus 1, and then put in the number of bits you expect, and then it'll give you the largest decimal number you can do, remembering that the 0 is always the number you're going to start at, okay? And you should always still remember that the least significant bit, it starts at the right. It's 2 to the 0. So 2 to the 0 is going to be your least significant bit, which is also called LSB. And then the leftmost bit is going to be your most significant bit, MSB. This is very important later on. The weights increase from right to left by a power of 2 for each bit, and that's why we're doing 2. This is mostly for an example, but I figured I would explain why we do this the way we're doing it. In my next video, I'll show you more examples.